Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be dealing with physical sciences. As we know, there are sciences. We have our physics, which is paper 1, which is our focus for today. And then we will just move to it to say, let's first look at the format of the question paper for the final exam. We are saying now our final exam, as the same was done during the prelim. It will be 10 multiple choice questions, which is 20 marks, and 130 marks for structured questions. And you will be sitting for 3 hours. Our topics is mechanics, which is 65 marks, wave, sound, and light, 15, electricity and magnetism, 55 marks, and metal and materials, 15. And when you add those numbers, they give you a total of 150. You'll be writing tomorrow on the 7th of November 2025. The paper will be marked externally. We'll try to do this and then finish everything. We are saying revision sharpens your skills. This is your chance to prepare for exam style questions. So we are more focused on the skills of how you go about answering the questions so that you are able to get as many marks as you can. So we're hoping this lesson will help you in doing just that. Now, without any wasting of time, we'll just start with it. Newton's laws of motion and forces. That is what you're expecting when you open your question paper. In terms of your question 2, you're expecting to have Newton's laws there. And then we are saying Newton's laws, first law, F net equals to 0 Newton. We are always emphasizing that F net equals to 0. It means that a body or an object will remain at rest or in constant motion unless acted upon by an external resultant force. So we're saying always remember that F net equals to 0. The 0 stands for the object remaining at rest and moving in a constant velocity unless it's acted upon by an unbalanced resultant force. Now, when it comes to Newton's second law, we are saying F net equals to ma. F net equals to ma is there in your data sheet. So we're simply saying, please go to the data sheet. It will help you to remember all these types of definitions or laws that we have to state. And we're saying when a net force is acting on an object, the object will accelerate. The net force acting on the object will accelerate in the direction of the net force. And we are saying you conclude by making acceleration the subject of the formula to say acceleration is directly proportional to the net force and inversely proportional to the mass. Please say all that for your 2 marks. And then you have Newton's third law, which in this case, we're talking about 2 objects. When body A exerts a force on body B will exert an equal but opposite force. Hence, we're putting the negative sign there. So please know all those laws. And we're saying for all the definitions, for all the laws, use your exam guideline. And we are having as well your Newton's law for universal gravitation. So remember that as well. And we are saying the F equals to G m1 m2 over r squared. Then you are able to see that we're talking about now the universal force of gravitation, which is now directly proportional to the product of those masses and inversely proportional to the square of the distance between the masses. So you are able to know that all these 4 laws of Newton's, you are expected to know them. Don't confuse Newton's law for universal gravitation with your Coulomb's law, where we're saying K, Q1, Q2 over r squared. And we're saying always know what happens if we increase the mass, what happens if we double both masses, what happens if we double the distance between them, and what happens if we halve any of them. So please ensure that you are able to do that. So we are emphasizing that. And then we are saying when it comes to Newton's law for universal gravitation, know that don't confuse it with Coulomb's law. With Coulomb's law, we're talking about charges, but with Newton's law for universal gravitation, we're talking about masses, the masses of the in the universe. Now we are saying problem-solving strategy when it comes to Newton's law. So we're saying in this application of Newton's laws, this is important. We are saying the most important factor that we're looking at there are the forces. So identify the forces acting on the object. So remember, it's all about forces here. And we're saying do that by drawing free body diagram and force diagram. I know by now you must be knowing how to draw free body diagram and force diagram. But however we're going to do questions, you'll be able to look at that. And always underline the keywords like rough surface. Immediately when you say rough surface, we're saying we have friction. When you say smooth surface, we're saying frictionless or no friction. So for questions involving calculations, we're saying this usually will be your routine straightforward questions that has 3 marks. So we're expecting you to write the formula, to substitute, and to write the answer. And always remember, we are saying FSAUT. We are saying formula, substitution, the final answer with the correct SI unit. Remember, if we don't write the correct SI unit, we're going to subtract that 1 mark. So it's very much important that every answer, as long as we have a unit, you will definitely show the unit. If we are dealing with vectors, you will show the directions as well. And we are saying when you have 4 or more marks, you will know that those usually will be your multi-step kind of questions. So that's what we are saying when you're dealing with Newton's laws. Datasheet is the most important thing that we're having, because remember, when it comes to definitions, when it comes to law, you will definitely go to the datasheet to remind yourselves to say Newton's second law, you will come there. You're just putting when there to say, oh, when the net force act on the object definitely has a mass m, so act on the object, and the object will accelerate in the direction of the net force. And we said acceleration is directly proportional to the net force and inversely proportional to the mass. So please remember all these formulas in the datasheet. They will help you in terms of reminding you some of the laws, some of the definitions, even in terms of calculation. When we do momentum, definitely you can see that momentum is the product of mass and velocity of an object. So you're able to get all of that. F net delta t, which is your impulse, you're able to get it from there to say impulse, it is the product of the net force acting on the object and the time taken when that force is acting on that object. So you can see your Newton's law for universal gravitation as well. You remind yourself all of those there. So we're saying datasheet, it is your friend. It's where you go, even when you are dealing with some of the definitions, some of the law, the datasheet will help you to answer those type of questions. Now, without any wasting of time, we'll go straight to it. Let's look at multiple choice questions. We are saying here under multiple choice questions, you are given at least 4 options, which means you are having 25% chances of getting the answer correct. Hence, I'm always emphasizing you can't leave a multiple choice question unanswered, because definitely when you say 1.1, you got to write A, B, C, or D. It doesn't matter. If you know that you are not sure, you have 2 answers, you just have to take a bet and choose one of those 4, because we are expecting you to have 1.1, 1.2, 1.3, up to 1.10, all of them being answered. You can't leave a multiple choice question unanswered. I'm emphasizing that. Let's look at this example that we're having here. We're saying several forces are acting on a moving object. They are acting on a moving object. Which one of the following statement is correct when these forces are in equilibrium? The key word there is equilibrium. So it's very much important to see that the task word is which. So this is what you are supposed to identify which one of these 4, which one. That is your task that you are having at hand, to identify which one of the following statement is correct. So you know that I'm looking for a correct, because sometimes you say identify which one is incorrect. So hence we're saying underline those keywords. They're able to help you in answering the question. And then we are saying here equilibrium. So you know at equilibrium we're talking about balanced forces. At equilibrium we have balanced forces. So when we have balanced forces, you know that we talked about Newton's first law to say it is only when we have an external unbalanced force that the object now won't remain at rest. But Newton's first law is saying an object will remain at rest or in constant velocity unless acted upon by an external unbalanced force. So when we have balanced forces, we're talking about equilibrium there. And then you are able to come in and say, okay, I can see this has to do with Newton's first law. The velocity of the object is increasing when the forces are balanced. No. When the forces are balanced, we have agreed that when the forces are balanced, it simply means that now the final velocity and the initial velocity are equal. So this is very much important. When final velocity and the initial velocity are equal, definitely when you want change in velocity, you will get 0. So we're saying the object is moving at constant velocity. No, the kinetic energy of the object is decreasing. No, sorry. The object is moving at a constant velocity, which is our number B there, will be the correct answer from Newton's first law. Remember we said an object will remain at rest or continue moving with constant velocity unless acted upon by an external unbalanced force. But this time we have balanced forces because we are saying we are at equilibrium. Hence, it must be constant velocity from Newton's first law. So that helps you to answer that type of multiple choice questions. So you have seen that you check which law, which principle applies to a question in order for you to get the correct answer. And then let's look at another question. This one is based on graphs. We have the expectation that as you are going to write exam, definitely you must go there with the skills of graphs. I just want to indicate that when you have a graph, you are having what we refer to as the y-axis and the x-axis. And you were writing maths not long. You know that when you talk about gradient, we're talking about change in y over change in x. That is your gradient. But now there is this one that we call area. Area, it will be, we are multiplying change in y and change in x. We are multiplying them. When we multiply the change in y and the y and the x, we get the area of a graph. But when we divide them, we get the gradient. I want you to have that. Now, when you look at this question, they're saying a stone is thrown vertically downwards from the top of a building. It takes time, t seconds, as shown in the graph. Consider the acceleration time graph below for the motion of the stone. The effects of air friction are ignored. What does the shaded area 0 to t seconds shown in the graph represent? Now, you are able to see that already I told you that the area is change in y multiplied by change in x. So you're able to check that, okay, if I multiply, what is our change in y? It is acceleration. So we have acceleration multiplied by time. Acceleration multiplied by time. If you want to take it further, you can even say meters per second squared, which is the SI unit for acceleration, multiplied by second, and you see that seconds and second will cancel. You will remain with meters per second. Definitely it must be a velocity. Now, by definition, if you define acceleration, you will know that acceleration is the rate of change in velocity. So you can see that when you cross multiply there, you find change in velocity, which is a delta t. So you're able to see that this is the area under this graph must be change in velocity. And you are able to see that the answer, the first option said the final velocity, no. The second option said change in position, no. The third option said constant velocity, wrong. The last option says change in velocity, which is the area under this graph, because the question said shaded area between 0 and t seconds. So definitely it is the change in velocity of the stone. So when you answer multiple choice questions, you must be sure. Remember, you have 20 marks here, which represent 13% of the paper. So hence we're saying answer all your multiple choice questions. Now, without any wasting of time, we move to Newton's laws, which is now your question 2. The scenario here, we are saying a force of magnitude 50 newtons is acting at an angle of 30 degrees on a 2 kg block to push the object against a rough horizontal ceiling. So you can see the object is on the ceiling, it's up there on the ceiling, and then the object accelerates to the left at 20 meters per second squared. So we're given acceleration. So you can see, if we are doing your data collection there, you can see that we are having our force F, which is 50 newtons, given there. We're having our angle with the horizontal, which is your 30 degrees. You are having acceleration as well as 20 meters per second squared. So that information is important. Always collect data, because that's what we are going to deal with now. And then the coefficient of kinetic friction between the object and the surface. Remember, they said the ceiling has a rough surface. So they're saying the coefficient of friction is unknown. Now, The first thing they say state Newton's second law of motion in waves. Definitely, you're going to remember when the net force acts on the object will accelerate in the direction of the net force. And we said the acceleration will be directly proportional to the net force and inversely proportional to the mass. So that's what you will see in waves, and this is what we are expected to write. When a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. So you get your 2 marks there. That's the expectation that definitely you will get those type of questions. Let's look at question 2.2. They're saying draw a level free body diagram indicating all forces acting on the object while in motion. 4 marks. That's very much important to know that 4 marks is showing you that how many forces do we have. We're having 4 forces, hence the marks are 4. So definitely. But now you got to, when you're drawing your free body diagram, remember by definition itself, you will be able to know how the force happens. I always say to learners, before you enter that exam room, you are having 1 mark of indicating FG, because FG is always vertically downwards. Just straight line going down with an arrow hit. That is your FG. So that mark, definitely you are having that mark. You got to be able to write FG. And then you are able to check the other forces. You are able to see that the force is acting on that direction. Definitely you are having a force that is working in that direction as we are moving. They said the ceiling is a rough surface. Definitely you are having another force that is opposing motion, which is frictional force. Remember, the object was accelerating to the left, so friction must be to the right because it opposes the motion. Now, the only thing that you are left with is your normal force. Normal force, I always say this to learners to say, normal force must be normal. What do I mean by that? Because by definition, a normal force is a force applied on an object by the what? By the surface. It's the force applied by the surface on an object. So where is our surface? The surface is under the surface. So definitely it is the surface that is applying the force. So the force will definitely go downwards because it's applied by the surface on the object. Because learners have a tendency of thinking that even in this scenario, the normal force will go up. Normal force will go up as long as the object is on top of the surface. But in this case, you can see that while having the surface at the top and having that, then the normal force will be in that direction. Otherwise, if this 2 kg block was on top of the surface, the normal force will be upward. And we are saying that normal force must always be perpendicular to the surface. So you draw your free body diagram, and then you are able to get your 4 marks there. So you can see it was quite a tricky question because of the object and the ceiling or the surface itself. To say it is the surface that is applying the force on the object, hence the normal force is going down. So always when you're drawing a normal force, it must be, you check the surface, and it must be the surface to the object. In this case, the object is downwards, so hence the force is going down. I hope you got that correct. Now, as we move, the question says, calculate the magnitude of the normal force. Remember, wherever you go in terms of calculation, you are always going with that free body diagram. You had your normal force downwards, you had your FG downwards, you had your applied force at an angle, you had your friction like that. We usually, though we are saying always draw the forces, but we're not saying spend time checking the sizes of the forces and all that, because we don't necessarily penalize for the sizes of the forces. But we are simply saying definitely friction when it's opposing motion, but there is motion, definitely friction will be smaller than the applied force. It's just scientifically correct. Now, they said calculate the normal force acting on the object. I know you know the formula for the kinetic friction, which is your kinetic friction, and then which is your mu k multiplied by the normal force. And then you know that on a horizontal plane, you are having mass force going downwards, vertically down, which is mg. You are having the normal force going upward, which is now mg as well. So we're having mg equals to mg. But in this case, we're having our force at an angle. Immediately when you have a force at an angle, you are forced to resolve that force before you do any calculation. I'm emphasizing that we're having our applied force 50 Newton is at an angle of 30 degrees. So this force is at an angle. So you must be able to resolve it to the horizontal component, which is where the object is going, fx, and your vertical component, which is Fy. So that's how you are going to resolve this applied force, because it's at an angle. You must have Fx, and remember, Fx we are referring to F cos theta, and then Fy we are referring to F sin theta. So please always remember that. It will definitely help you. Then you had your normal force that was downwards, and you are having your Fg that was downwards. Immediately when you have that, you are set. We had friction that was opposing motion. We are saying resolve the forces for the sake of doing calculations. But when you say draw the forces, just draw the forces as they appear. You don't have to resolve the force that is at an angle. Now, as we move, definitely for you to be able to get, remember, you are having Fy, which is equals to normal force plus Fg in this case. They are equal. Otherwise, if they were not equal, it means the object will either move upward or downwards, because it means that the forces are not balanced. So we are saying the forces on the vertical plane are balanced, hence Fy equals to Fn plus that. So if we have to calculate, because the question is saying calculate the normal force, definitely we'll make Fn subject to the formula, which will be Fn equals to Fy minus Fg. So immediately when you do that, you are able to see that, okay, let's check. Fy, don't forget Fy is F sin theta. Fy is F sin theta. And then don't forget you are having your Fg, which is mg. And then that is equal to normal force, which is what we are having there. So you just have to substitute, and definitely F sin theta we have shown here is 50 sin 30, which is equal to 25. So you are having 25. Mg is 2 times 9,8, and then you are able to get your normal force as 5,4 Newton. So practice as many of these questions as possible. I know it will definitely help you. Now, as we move, the question says, calculate the magnitude of the coefficient of kinetic friction. So the question is coming back again. Don't forget, for you, always at the back of your mind, you are having your free body diagram with the forces being resolved. So you are having your Fx, you are having your friction opposing the motion, you are having your Fy, you are having your normal force that was downwards this time, and you are having your Fg that was downwards as well. So immediately when you have that, you are able as well to look at that and say, okay, fine, now they want coefficient of kinetic friction. So they are talking about kinetic friction, which is this one, which is on the horizontal plane. So you can see that here I can use F net equals to MA, and then I can be able to look for the coefficient of kinetic friction, because that's what will help you. Hence, when you do this question, you will definitely start by looking at, let's look at Fx, for example, which is on the horizontal where the object is moving. And then that is F cos theta, which is 50 cos theta, and that is equals to 43,0301. So immediately when you say F net equals to MA, you are saying the force is these forces that are on the horizontal plane. These are the ones that you are having, which is your Fx plus Fk. So hence we are saying plus, because F net means add, sum. It means sum. Net means add. So we're adding Fx and Fk, but don't forget Fx is going where the object is, so that will be our positive direction, and Fk is opposing the motion. That will be our negative direction. That's why we have negative there. We just substitute Fx 43,301, and then your Ma, we're given the mass is 2 kg. We know acceleration was given as 20 meters per second squared. Then you are able to substitute there, and then you get kinetic friction, which is 3,301. And immediately, you know we have calculated the normal force. We said it's 5,4 in the previous question. Now we calculate the kinetic friction. So you are able to do the substitution, and then with no any waste of time, you'll have 3,301 divided by 5,4, and that will give you the coefficient of kinetic friction. So we're saying please always know that. And it's very much important that to be able to apply the Newton's second law, F net equals to ma. Now 2.4, they are saying the force is now acting at a smaller angle. The force is now, so they're changing. The force is no longer at 30 degrees. You can just put 20 degrees, for example. So the force is now acting at a smaller angle. What effect will this have on the following? Choose from increases, decreases, or remain the same. You can try it and just decrease the forces and see what will be the effect. I've seen you said 50 sine 30. It was giving you the answer of 50 sine 30. What did you get for 50 sine 30? It was giving you another answer. Definitely when you do it, you will see that as you decrease the angle, definitely you are going to have now something that is going to change. So we're going to make the angle small. What is the effect on 2.3.2? Remember 2.3.2, it was the coefficient of kinetic friction, which was 0.61. There are no SI unit for the coefficient of kinetic friction. And immediately when you have that, they are saying, what is the effect now of changing the angle? Remember, the coefficient of kinetic friction depends on the surface itself. It's not dependent on the normal force or the angle that you are changing and all that. So you are able to check that the coefficient will remain the same because we are not changing the surface in the ceiling. But now the next question is, what will happen to the kinetic frictional force? What will happen to the kinetic frictional force? Remember, and then as you decrease that, we're expecting that the normal force will decrease. If the normal force, remember from the formula, kinetic friction equals to the coefficient times normal force. We are saying if we decrease now the normal force, the Fk as well will decrease. That's why our answer is decreases. And we are saying the normal force will decrease, and as with the decrease in size of the angle. So as the angle decreases, normal force decreases, and when normal force decreases, even the kinetic frictional force will decrease. So that is it in terms of your expectation for question 2 or Newton's laws that I have for you. The main thing there, F net equals to ma, the application of Newton's second law is very much important in terms of that. Now, for your question 3, you will be dealing with vertical projectile motion. And then, the expectation is that you must know how to define a projectile. Because we are saying a projectile is when the object has been given an initial velocity and the object moves under the influence of gravitational force. So this one, it must be given initial velocity. The object must be given initial velocity and is moving under the influence of the gravitational force only. Don't forget only there, it's important. The only force acting on that object is the gravitational force. And then when it comes to free fall motion, we're saying this motion is a motion. So when we're defining this, learners, we are strict on this one to say, if we say free fall, the key word that we want to see is that free fall is motion. The object is motion, during which the only force acting on an object is the gravitational force. When you say define a projectile, you will definitely start by saying it's an object. And we are saying you must know how to sketch the graph to determine the position time graph, velocity time graph, as well as the acceleration time graph. And you must be able to describe the motion. And then we are saying the equations of motion. Our equations of motions, you know them by now, and then be able to utilize them. They are there in your data sheet. And then after data collection, you must be able to use them. Now, without any wasting of time, we are going to look at question 3 here to say now, we're having a ball that is dropped from rest. You're underlining rest, dropped. Immediately when you say dropped, we're giving you a value. We're saying the initial velocity is 0 meters per second. From the top of the building, which is 15.2 meters high, after a ball has fallen 3.2 meters. So when the ball is here at 3.2 meters, a second ball is projected vertically upward. That's what we refer as our projectile. Because when it's projected upward, it means it has been given initial velocity. And they're saying after a while, the two balls strike the ground at the same time. So definitely this second ball, it means it's not going to go past ball A. They must meet somewhere and move downwards so that they are able to reach the ground at the same time. And then we're saying ignore the effects of air resistance. The first thing is define the term free fall. I've emphasized on this definition to say you will definitely start by saying it's a motion. So motion under which the only force acting on the object is the force of gravity. And we are saying question 3.2, calculate the time taken for ball A to strike the ground. This is very much important. Immediately when say for ball A to strike the ground, you know already that its initial velocity here was 0 meters per second because it was dropped. You know that the building is 15.2 meters. You know that the object, because they ignore the effect of air resistance, is simply saying that the only force that is acting there is acceleration, so your gravitational acceleration, which is g, which is always 9.8 meters per second squared downwards. So those are given information. You have 3 information. You are able to choose your formula and be able to answer the question. And that's what we are dealing with. Say always data collection. And without wasting time, you choose the correct formula. Change in y equals to VIT plus half AT squared. You know change in y is negative 15.2. Remember, it depends whether you are saying downward is positive or upward is positive. So hence, when we give you 2 options, we have option of downward is positive and downward is negative. I hope you get that. And you are able to calculate the time after substitution and substitute correctly to say initial velocity is 0, acceleration is 9.8, and we are looking for time. And then you make time subject of the formula, you are able to get your answer. Now, when we move to 3.2, we're saying calculate the magnitude of the velocity with which the ball was projected from the ground. So now we are coming to this ball to say, okay, as it was going up, what was the velocity that it was given? So in this case, you will definitely start by choosing your direction, as you always do, to say choose the positive direction. We have found already that for ball A to reach here the ground, the time was 1.76 seconds. We have established that in our previous answer. Now, as we are coming here, we're going now to check how, because ball B was only projected when ball A was here at 3.2, when it has moved already 3.2. So we're going to measure the time it took ball A to reach 3.2. And then when we do that, using the same formula, changing y equals to VI delta t plus AT squared, we're able to do the substitution. And when you substitute, you get the time it taken to reach the which is 0.81 seconds. So it took us 0.81 seconds to reach that point where ball A has traveled 3.2 meters. And then if you check now, by so doing, we'll be getting the total time taken by B to go up and come down to the ground, which means we're going to say 1.76, which is the total time taken by A. We subtract 0.81 because B was not there in the event when A was moving for 0.81 second. But after this 0.81, they are moving, all of them. B is going up, A is going down. Hence, we are saying 0.9 seconds is the time that both A and B took after the 3.2 point there. And then without wasting of time, you are able to say, okay, if we're to do the calculation, we can say change in y, VIT plus half AT squared. And then you are able to see that, okay, if now the distance, when it comes back here, the distance will be 0, your displacement. And then you are having your time, which is 0.95. And then you just do the substitution and get the initial velocity, which is 4.66 meters per second. I hope you will practice many different options, even this one of 2 balls, where we throw another one. Sometimes we throw the first one downwards, the second one downwards. Sometimes in this event, one is going down ball, the other ball is going up. So practice all these scenarios so that you are ready for your paper. Now, when it comes to now on this one, on the same set of axes, draw position time graph to show the motion of both ball A and ball B. Now, when you are drawing the graph, the most important thing is that when it's position time graph, Usually we're talking about your curves type of a graph. And then when it's a velocity time graph, we are talking usually of your graph, straight line graphs like that. Can start at the origin, or it can start if we have initial velocity, like when we're having a projectile, it will definitely start at a particular point. That is your velocity time graph. But in your position time graph, always look at the motion that is given. In this case, we had ball A that was was dropped downwards. It was going downwards, so you can see that it's going to look like that, going downwards. You had another ball, which is ball B, which was thrown up and it came down. So in a graph, you're expecting to have such type of a graph when you're throwing this motion, and definitely that's what you will do. To say we are starting, the height of the building was 15,2. We are dropping ball A until it reaches the ground. Ball B was thrown from 0.81 seconds. We thrown ball B up, it went up, and then it came at 1.76 because they all reached the ground at the same time. This is for upward is positive. So when you're drawing the graph for upward is positive, the graph will look just the same as what is occurring. But when you say downward is positive, you got now to draw the graph on the downward is positive side. So that is the two difference that you must have. Now, on your question 4, you'll be focusing now on momentum. There are definitions here. Remember, I'm always emphasizing definitions. I've emphasized definitions for question 2 or for Newton's laws, which is Newton's first law, second law, third law, and universal gravitation. I've emphasized the normal force. You must know how to define normal force, know how to define the kinetic friction. Remember, we have kinetic friction and static friction. Know how to define your inertia as well. So that is for question 2. But now, for question 3, we said the most important definition is your projectile and your free fall. Now, when you come to question 4, which is now linear momentum and impacts, we're saying be able to define momentum just from the datasheet P equals mv. You see your definition there in ways. Newton's second law in terms of linear momentum, impulse, isolated system, principle of conservation of linear momentum, elastic versus inelastic collision. Now, without wasting time, let's look at a problem, because I want us to look at different problems so that when you go to write your questions, you know how to come to this particular to solve this problem. So we're saying a car of mass 1,200 kilograms. Very much important, the mass, to say the car has that mass, moving at a speed of 25 meters per second in the eastern direction. So it's going to the east, crashes at the back of the truck. So you can see we have a truck. So you can even do your data collection there to say, okay, the mass of the car is 125, is 1,200 kg, and then the velocity there was 25 meters per second. Then you go to the truck. The truck is 6,000 kg. The truck is 6,000 kg. That is the mass of the truck. And then the velocity of the truck is 15 meters per second. So very much important for data collection. And then they are saying the velocity of the car after the collision is 16. So you can see it was 25. It has decreased now to 16 meters per second. And then ignore all frictional and rotational effects. Now, without wasting time, write the principle of conservation of linear momentum in waves. Now, on this one, I want to emphasize that as long as the question is saying the principle of conservation, you definitely going to say of what? Of linear momentum. You will say the total. All you are putting there is the total linear momentum. Total linear momentum in an isolated system is conserved. The principle of conservation of mechanical energy, total mechanical energy of an isolated system is conserved. So all you are putting is the total of an isolated system is conserved. Whatever we say, state the principle of conservation. That's how you would state it. So please collect those marks. So in this one, it's linear momentum. Definitely, you are going to say it. Total linear momentum of an isolated system remains constant or is conserved. Because it's saying conservation, I like it because it just say it must be conserved, because it's a principle of conservation. So it must be conserved. So all you are putting is the total what? Linear momentum of an isolated system remains the same or is conserved. Now, calculate the velocity of the truck after the collision. Now, on questions like this, the most important thing is to be that data collection that you have done, because you're definitely going to utilize it here, and then you're going to use your principle, which will always give you the first mark for writing the principle, which is now you are having your momentum there. The sum total of your initial momentum is equals to the sum of your final momentum. And then when you do that, it's either you will do that or you will do that to say it's the mass of the car and the initial velocity of the car, the mass of the truck and the initial velocity of the truck. We don't care. You can even use M1 V1 plus M2 V2. As long as we know that M1, you are saying if your car saying car is 1, this one will be 2, this one will be 1, this one will be 2. So you can use M1 V1 equals to M2 V2, which is equals to that is the V, it must be initial and the V must be initial. On the product side, we have the final, so it will be M1 V1 final plus M2 V2 final. So we expect you to do that as well. And this is one of the formulas that is not in your data sheet. So definitely you do that. And check if after the collision, the object, they're going to move together, coupling. They're going to become a couple and move together. Definitely, when you write your equal sign, you will say M1 plus M2, and then you multiply that by the final velocity. So you are able to do that. In this case, they collided, and then the velocity of the car is moving with its own velocity, hence we didn't couple them like that. And then you are able to say calculate the velocity of the truck after. So you have to calculate the velocity of the truck, and then all you do is to substitute. You say initial, this is before. You go to before, it was 1,225. We are just taking the information. Final initial for the truck, it was 6,000 kg of the 50. Finally, we're still having the car, which is 1,200, but it's moving with 16. For the truck, it's still 6,000, but we want to know it's now. Remember, for the truck is 16. We want to know what is the speed now of the truck, and then we're able to say is 16.8 meters per second, and all of them are going to the east. Definitely, it will be to the east, and then you are able to get your mark. So please collect those marks. Be careful when the two objects are moving in different direction. You have a duty to choose a positive direction, to say to the east or to the north, to the west is positive, and then be able to substitute those positives and negatives. Now, to conclude our momentum, they are saying calculate the mechanical energy lost during the car truck collision. During this collision, what is the mechanical energy that was lost? You must calculate it. So we can ask you mechanical energy. We integrate the topics as well. So don't say, hey, I'm doing question 4. Now they're talking about mechanical energy. Remember now what happens. We are saying EK before, which is the sum now of these two before. So it's the EK of the car, which is half mv squared, half 1,002 times 25. For the truck, it was half 6,015 because it was moving with 15 initial. Then we go to the after. After we know the car was now moving at 16, the truck was moving with 16.8. We just substitute them, and then we were able to subtract the two to check how much energy was lost. So immediately when you do that, you say EK lost, you are saying, okay, after waving that number minus that number of the EK before, and then we're getting 4,980 joules. So definitely you are able now to see that, okay, this is how much energy that was lost, the EK lost. So immediately if EK is lost, we are saying that this is an inelastic collision, because in an elastic collision, the two must be equal, which means if I am to subtract them, I must get 0. When I get 0 joules, I know that this is an elastic collision because the two are equal. But in this case, there is now 4,980 joules that are lost. Now, explain why mechanical energy is lost. I think I've responded to that question by saying this collision will be inelastic, because there is energy that is lost as sound energy and heat during the collision. So as the car collides with the truck, there will be some energy. In real essence, energy is transformed from one form to another, which in this case we're saying it has been transformed to sound energy and heat during the collision. That's why we lose some energy, and that is your momentum. Now your popular work, energy and power, and then as well here we are saying know that definition. Remember 2024 final exam we had a question on you having to define work done on an object. So be able to always remember that F delta X cos theta, what it talks to say this is the product of your force and your displacement in the direction of that displacement. And then you are able to get that one. And then be able to say when do we have a positive work done and when do we have a negative work done. And in these two, we are talking the relationship between the force and delta X to say if the two are in the same direction, definitely the two same direction will mean that cos 0, which means that positive work is done. So positive work is done when F and delta X are in the same direction. And then when the two are opposing one another, like when we have friction, for example, the object is moving in that direction, friction on the opposite will have cos 180, and F delta X cos 180 will be negative work done. So that's when always you are looking at the relationship between the force and displacement. And if the force is perpendicular to delta X, you know this one to say, okay, they're forming 90 degrees, which means F delta X cos 90 and cos 90 degrees is 0. So this becomes no work is done. So negative work is done when negative work is done when the force and the displacement are in opposite direction, when the object is going where the force is going, or when the displacement and the force are in the same direction, positive work is done. And then no work is done when the force and delta X are perpendicular. And then when it comes to the principle of conservation of energy, your work energy theorem, your conservative and non-conservative force, your power, definitely we are saying these definitions are songs that we are saying according to the exam guideline. Now, when you are working out this, so that's why I would always advise learners when they are revising to say, if you are dealing with Newton's laws, F net equals to ma, you're dealing with the force diagram, the free body diagram, it's better to even do work energy and power, because even in it is the force still that is doing the work here. So still you will be expected to draw the free body diagram and the force diagram and to identify the force that do the positive work and the force that does the negative work. And we are still saying copy the formula from the data sheet. Don't come with your own formulas unless we are talking about the conservation of linear momentum, where I indicated that you will write the formula, though you won't have it in your data sheet. Now, the angle theta is between the force and displacement. We talked about that. And ensure that all quantities substituted in the formula are in the correct SI unit. For example, your mass there, we said it's in kilograms. So you got to be able to convert everything to the right SI unit. And then that is your data sheet for work energy and power is written in your data sheet. You know that that's what you'll be using when you're dealing with this question. Now, without wasting time, remember we're focusing on problem solving. Now, this one is saying a small toy roller coaster of mass 6 kg. So you can see it's driven from rest. Important is 6 kg, the mass, and it's from rest, which means initial velocity is 0. Up an inclined plane. So it's going up an inclined plane, which is AB, with a driving force. So we're having the applied force of 140 Newton. You can even indicate the force so that you don't forget that we have a force here of 140 Newton that is driving it upward. It experiences a frictional force of 20 Newtons. Oh, there is friction as well. That is opposing motion of 20 Newton, definitely smaller than the applied force, which is 140. Hence, the object is going up. The distance of AB is 5 meters. So we're given delta X there. So you can see the kind of information that we are receiving. And then the angle of inclination is 30 degrees. Let's go to questions. State work energy theorem. Definitely, we are going to refer to a data sheet where we have work net equals to change in kinetic energy. And you will write it in ways to say the net work done on an object by a force. That work is done by a force is equal to the change in kinetic energy. And then just for saying that, you have 2 marks. Please don't lose marks on definitions. Now, Draw a labeled free body diagram. That's the nice part about it. You are able to be asked free body diagrams on question 2 or in your Newton's laws and in your question 5 or in your work, energy, and power. So we're saying draw a labeled free body diagram showing all the forces acting on the toy roller coaster as it moves along AB. 4 marks. That 4, very much important. It's telling you the forces. I told you that we don't expect you now to resolve the forces. Just draw the forces to say, okay, we have the object as a dot there, and then we have the applied force, we have the friction that is opposing the motion, we have Fg. I told you when we started this lesson that this force Fg, you have it when you are still at home. You just have to write it vertical downwards. Will award you 1 mark. And then you have your normal force. And I always say to the learners, your normal force must be normal. What does that mean? I'm saying your normal force must be perpendicular to the surface. It must make an angle of 90. So some learners will draw this force, but you will have 2 unequal angles. It will be towards that side or toward. No, it must be able to form here 2 equal angles of 90 each. Please, hence we are saying it's always perpendicular to the surface. And you can see in this case, our object is on top of the surface. Hence, the normal force will be upward. You have seen on the ceiling was the surface, the object was under the ceiling, hence the normal force was downward. I hope that helps you. And remember, if we have no surface, we won't have friction, I won't have a normal force. So emphasize that to say normal force, it needs a surface that we have it because it's applied by the surface on the object. Draw free body diagram. I've drawn it for you. You're able to draw. You have 4 marks written by drawing it. And then it must be everything. They must touch. The forces must all of them. They touch that dot at the middle, and we have arrowheads. So everything must be clean and label all your forces, and you get all your marks there with no wasting of time. We move to questions now to say using energy principles only. So you are using energy principle. Remember your energy principle, you know work net equals to change in kinetic energy, you know your work done by conservative force, which is your change in EP plus change in EK. You are having now another energy principle, which is mechanical energy. The sum total of mechanical energy at a point is equal to the sum total of mechanical energy at another particular point. So they're saying use only these ones to calculate the speed at which the roller coaster reaches point B. They're saying, oh, it's going to reach point B, but we want to know the speed. So very much important for you to say, okay, I have a lot of information here. But now, if you check here, you can as well draw that line here and complete your right angle triangle. And you're able to see that I'm going to have an H here. So you can use your maths then. For example, sine 30 opposite over hypotenuse. So you're able to get your height. And if you get your height, you will get your MGH. Remember, that will help you if you want to use the mechanical energy or you want to use the work energy theorem as well. It will help you to do that. And that is the skill you are giving to yourself to say, okay, you can say I'm going to use this principle, which is the work energy theorem. Work net equals to change in kinetic energy. You're going to identify all the forces that are doing work. In this case, what you got to check here is that this Fg, remember Fg is always downwards. We said Fg is always downwards. But now we're having an incline there. So you can see there is an angle between Fg and the surface of the incline there. There is an angle there, which means now we got to resolve Fg, because when I started this lesson, I said always you will resolve the force that has an angle with your surface. In this case, the force that is having the angle there with that surface is Fg, and our Fg must be resolved. And when you resolve Fg, you're going to resolve it into the Fg perpendicular, and then you know now you had your Fg parallel, which will be in this direction, opposing the motion. So it's Fg parallel and Fg perpendicular, and you had friction that was opposing the motion. There was friction. We had our 140 applied force there. So these are the forces that you are having. So you can see that if we are having that, we had our normal force, which said it must be normal. Then we have our normal force there. And we're saying FG perpendicular and Fn, they must be balanced. They must be balanced, these ones, so that the object doesn't move up and down. So they equal, hence we're going to ignore these forces because they're equal. We're going to concentrate on these three forces that are going to do work. The applied force of 140, which is what we're having here. So definitely it's the work done by the applied force, the work done by the FG parallel, the work done by the friction. Normal force is not doing any work, and FG perpendicular not doing work. Why? Cos 90. Cos 90, we said no work is done. So you see that the forces that we focus on are these along where the object is moving. And then you are able to say, okay, if I'm to talk about a frictional force is 20, delta x is 5, cos 180 because it's opposing motion. When it comes to applied force, it's 140 delta x cos 0, and then it gives us that. And then when it comes to your work done by gravity, you are having your mgh sin theta, which is what you are having there. And then you are able to have your 6, which is your mass, your g, which is 9,8, sin 30, your angle, and then is opposing motion. That is your mg sin theta. Mg sin theta, you're able to see that your mass is 6, your g is 9,8, sine is 30, your delta x is 5, and then cos 180. And then you are able to do your calculations with no problem. That is equals to change in kinetic energy, which is half mv squared final minus half mv initial. Remember, the object started from rest, so initial was 0. Then you just do that. You are able to find your final velocity. I hope you will apply those skills and they will help you as you deal with this type of questions. Now, the question now continues to say, when the toy roller coaster reaches the top of the incline at B, when the roller coaster reaches here, the engine is switched off and it rolls from B along a horizontal frictionless track to C. So you're just rolling here up to here. It then continues down a frictionless curved track to D. Now they're saying calculate the speed of the toy roller coaster at point D. Very much important. I like this question because at least it has those two principles that we can apply there. So you can use all the options. You can use your work done equals to change in kinetic energy. We only have, remember immediately when we say frictionless, we're talking about conservative force. Conservative force here. So definitely the only force is the force of gravity. So the work is done by the force of gravity, which is your work net, and then change in kinetic energy. And then you just substitute your 6 is your mgh cos theta. And you got your h there. We said your h there. You will say sin 30 equals to opposite h over 5. Then you get that, which is your mgh. Then you get your h is 2,5 cos 0, because that's where the object is moving, same direction. And then you are able to find your final velocity as 14,144. So I hope you will do that. And here you can even use mechanical energy and then add C there, and mechanical energy at D. Remember, the velocity there was 12, as we're given in the previous 12, I think it was 12,2, and then you are able to do that. And then you are able to get your answer. 12,29, yes. Your velocity was 12,29. So that is your velocity there. It was 12,29 as we're told. And then you are able now to find the final velocity. So initial velocity is 12,29. You substitute, you calculate the final velocity. You get your answer. I hope this helps you in terms of mechanics. And you are saying, come mechanics, I'm ready. Now let's look at Doppler effect. Doppler effect, which is wave sound and light. Remember, I said we have 15 marks that are budgeted for under Doppler effect. Now, we are saying the first thing, which is very much important, is to be able to state Doppler effect. I always say, look at the formula itself. We're saying Doppler effect is the change in frequency of the sound, change in frequency. I usually just write it like this: change in frequency of the sound detected by the listener. That is change in Fn. Change in frequency of sound detected by the listener. And then that is the first part of the definition: change in frequency of the sound detected by a listener. Why? Why is it like that? Because the sound source and the listener have different velocity. The sound source and the listener have different velocity. So we're simply saying there that the velocity of the listener and the velocity of the sound cannot be the same. They must have different velocities. That's what we're saying. That's why we're going to have a change in frequency of sound detected by the listener. Why? Because the sound source and the listener have different velocity relative to the medium of sound propagation. Remember, sound depends on the medium. It can be in air, in water. They will have a different speed in terms of the medium. So it depends. Hence, we're saying relative to the medium of sound propagation. And then we're saying as well, you must be able to explain using appropriate example, change in pitch, and then towards and away from the listener. You must be able to solve problems using this question, and you must be able to state the applications of Doppler effect. And for grade 12, you are not doing blue shift, you only explain the red shift. With light, red shifts in the universe, evidence of the expanding universe, by saying use the Doppler effect to explain why we conclude that the universe is expanding. That's the expectation. That's where your 15 marks is supposed to come from. So I'm hoping that you are busy with the practicing of Doppler effect as well, because that 15 marks is important. Remember, 15 out of 150 is 10%. So that is 10% of your paper. So you can't afford to lose that. Remember, 10% in your certificate, it will look good in your statement of results. Now let's look at an example. We are saying here now, an ambulance moves away from a stationary listener with a constant velocity of 25 meters per second. The ambulance siren emits waves at a frequency of 550. So you can see a stationary listener. Already we're saying the speed of a listener is 0 because it's stationary, 0 meters per second. With a constant, the ambulance is the one that is moving with a constant velocity. So velocity of the source is 25 meters per second. So please, data collection, data collection, data collection. And we're saying the ambulance siren emits sound waves of frequency 500. The ambulance, that is the source, is emitting that. So that is the frequency of the source. Very much important. The listener detects the frequency of these sound waves to be 512.64 hertz. So you know that is the frequency of the listener. You can see it's different. The source is producing, the ambulance is producing 550 hertz. The listener is receiving or is detecting 512. So you can see that if this ambulance was coming closer to the listener, definitely it was going to increase the frequency of the listener. But this time it's decreasing, which means it must be moving away. Now, as we said it, we will always start with stating the Doppler effect. And we said it was a change in the frequency of sound detected by the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. So medium of sound propagation is important. Use the given information to calculate the speed of sound in air. Definitely, you're going to copy the formula. I emphasize this. Copy the formula as it appears in the data sheet. But you can't be able to, before you do that, data collection. Frequency of the listener, the speed of the listener. This listener was stationary, 0. Frequency of the source was 550 hertz. And then the speed of the source was 25. We're looking for the speed of sound in air, which must be a constant of some sort. That's what we are calculating. Now, I always emphasize to say to learners, please just start by copying the formula as it appears in the data sheet. Please, we are pleading with you. Then you just dress your formula nicely. Now you have checked, okay, is it moving away or towards? That's what you got to look at. Remember, on the formula there, we're having V plus or minus VL over V plus or minus VS. So we're saying if it's coming towards the denominator, it must be V plus VL over V minus VS. That is multiplied by Fs. That will be your frequency of the listener. It will be like that, which means we must have a smaller, the number that we're dividing with must be smaller, hence it must be negative there. That is away. So you're able to look there to say, okay, we know that this was away because the source 550, the listener 512. So it is moving away. Then when it's away, we are saying now we have a bigger number here that you are dividing with here. Hence, you're going to have plus here, because is, so we're saying towards, you'll write plus over minus. Away is minus over plus in terms of here, plus over minus. For towards, away is minus over plus. So on this one, it's going to be minus over plus, hence we're having a plus. Remember, we said either the source or the listener is stationary. So in this case, it is the listener who's stationary. So it will be 0 for the listener. We just write there plus. We said this plus, so it's minus 0. So v minus 0 is v. That's why we wrote it like that. And then you just do the substitution, and then you are getting all your marks. Please learn to utilize the calculator. It's good that you are consistent. You use one calculator throughout. Always use the calculator that you know, so that you are not wasting more time. And then you are able to do your calculations and you get your 5 marks. So I'm hoping you will collect these data marks based on Doppler effect. Now, an ambulance, okay, safe statement. They are saying now, if the ambulance moves away from the stationary listener with a constant velocity, which is greater than 25, it's just increasing the speed, it's now greater than 25, how will each of the following change? Choose from increase, decreases, or remain the same. You can't write any other answer except increases, decreases, or remain the same. One of those. That's the instruction. It's simple. You are choosing either increases, decreases, or remain the same. Don't do anything except that. The speed of sound in air. The speed of sound in air. Will it depend on the speed of the source, whether it's moving with a greater speed or not? Remember, the speed of sound in air, in water, those are constant. So you got to know that definitely it will remain the same. And then the frequency of the sound waves emitted by the siren. The siren is going to emit definitely the same amount of frequency. Remember, it's the same source. We're not changing the source. So the frequency will be the same. The frequency of the sound waves detected by the listener. Yeah, you see this one now. As the wavelength increases, the distance between the source and the listener increases, definitely we're expecting that the frequency will decrease. So we're saying here, remember the relationship, we're saying V equals to F lambda, don't forget that. And then we are simply saying that in this case, when the wavelength increases, the relationship is inversely proportional. When the wavelength increases, the frequency will decrease. So when it moves away, that is our distance away from, that is our wavelength, the frequency will decrease. And so we're saying the frequency detected by the listener decreases, not of the source, but of the listener. The source is producing the same sound throughout. Hope that helps you when it comes to Doppler effect. And we're saying the spectrum of distant star when viewed from the Earth is redshifted. You know, redshift, always emphasizing your ROIC beef there, your ROIC beef, to say, okay, don't forget, we are saying the sky is blue. So you can see the distance between us and the sky is smaller. But when you see there where the galaxies are, where the stars are, it's red. So when we're increasing the wavelength, we are moving towards the red. When we're decreasing, we're moving towards the blue, towards us, towards the Earth. Hence, redshift is when we are moving, the wavelength increases. It will simply mean that when the wavelength increases, we are moving away. We are having what is called redshift. So, wavelength increases simply means that the frequency decreases. And when the frequency decreases, the energy decreases as well. Now, they're saying, is the star moving away from or towards the Earth? So, it must be, for the wavelength to increase, it must be away. So, definitely, we're saying now it is moving away from. Now, use the Doppler effect to explain the answer to question 6.2.1, which is what I was saying, to say a lower frequency means longer wavelength. So when we increase the wavelength, we are definitely moving towards the redshift, and the spectral lines are shifted to the red end of the spectrum. So just have that and you understand redshift. And that is your marks for Doppler effect. Now, we are moving. electrostatics. You started this in grade 10 when you've done the principle of conservation of charge. You have done your Coulomb's law. You have done you have done your Coulomb's law in grade 11. You have done your electric fields and electric fields at a point, and we're expecting you to know all those definitions, more especially your Coulomb's law. Remember when I started, I've indicated the Newton's law for universal gravitation. To say with that one, we are talking about mass, but with Coulomb's law, we're talking about the charges, and it's given in the data sheet like that. And then when you are setting the law, you are simply removing the equal sign and the constant there. To say, okay, we're having the electrostatic force of attraction or repulsion, which is now directly proportional to the magnitude of your Q1 and Q2. So we're saying that the product of Q1 and Q2 over R squared, that will be your Coulomb's law. And electric fields, we're saying this one is a region in space where a charge will experience a force. So go to the exam guideline, look, make sure. I'm not asking a lot here for you guys. I'm saying, no, it is these three. You can't go to the exam without knowing them, because most of the time, one or two of them, you will find them in the paper. Electric field at a point, we're simply saying, come here. What do you read this? Is a force per unit positive charge of a coulomb. Then you're getting your 2 marks for saying that. So please, no, electric field at a point is this one. Electric field, we're saying it's a region in space where a charge will experience a force. I hope you will get these formulas as we move. Now we're having 2-point charges, which is now your X and Y are held 0.03 meters apart, as shown in the diagram below. Let me show you the diagram. And then we are saying the charge of X is 7.2 times 10 to the power minus 9. That is nanocoulomb, 7.2 nanocoulomb, negative. Very much important, that sign. And then while the charge of Y is positive 7.2 times 10 to the power minus 9, or positive 7.2 nanocoulomb. I find it very much important here that you must be able to move from your nanocoulomb, your microcoulomb, your picocoulomb, all those coulombs, to know that nanocoulomb we're saying times 10 to the power minus 9 times 10 to the power minus 6, so that you don't forget times 10 to the power minus 12, so that you don't lose marks of conventions. So I hope you have that and you will be able to do that. Now, and your distance must be in meters, because we can give you centimeters. Expectation is to divide by your 100, so that you are able to move to the right what is expected of yourself. So please have the correct SI unit. Now, what do we have as a question? State Coulomb's law. So you're going to state Coulomb's law to say the magnitude of the electrostatic force exerted by one charge on another charge is directly proportional. Okay, that is your F equals to K, Q1, Q2 over R squared. So you are saying the magnitude of the electrostatic force exerted by one charge Q1 on Q2 is directly proportional to the product of the magnitude of the charges. That is where your first mark and then your other mark. Usually we don't do part marking. We just say 2 or nothing. So it's better to know the whole definition than to know parts of the definitions. Okay? Draw the net electric field pattern due to the 2-point charges. So it's very much important. You are having them. It's a negative and a positive. Definitely, you're going to draw them like that. Remember, we are looking at positive, which is your Y here. It's positive, negative is your X. And then the arrows are always moving towards from positive. So we're looking at positive as your repulsion and negative as your attraction. So the arrows will always, or our electric field patterns will always be from positive to negative. And when we are marking, this is very much important. Remember, if these two were all positive, for example, they're not going to touch one another. They are going to be shy to touch one another, and then they will have them like that. Now, if they were all positive, if they were all negative, the same, they're not going to touch one another, shy. They must always touch our cycle there. Please, you will see I'm going to talk about the criteria. How do we mark if they're all negative? The important there is the sign to say when it's negative, it's towards. The arrowheads must be towards the center there. Yeah, and then they are towards, but they are not touching one another because the like charges, they repel. And then the positive, they are doing the same, and then they won't touch one another like that. And then we see that this is our repulsion. So this is our repulsion. But in this case, we're given a negative and a positive. They will clearly hug or come together. Hence, we're saying you'll get 1 mark for the correct shape, 1 mark for correct direction from positive to negative. Always, you can see the arrowheads. They are always, every line that you are drawing must have an arrowhead that goes away from positive. And then lines not crossing. If these lines, they cross, we're subtracting a mark. So make sure that they don't cross. Lastly, they must not touch. So we can be positive and positive. It will be like that. Positive and negative, and negative and negative. Then I hope this helps you how to draw electric field patterns. Calculate the magnitude of the electrostatic force that Y exerts on X. The force that Y exerts on X. So that is for 3 marks. You have to just calculate the force. So you just write the formula and then you do your substitution. K is our constant, 9 times 10 to the power of 9. And then you write your 7,2. You can see when you substitute on the Coulomb's law, the formula there, we are not putting the negative sign and the positive sign. We're just putting the charges in it. And then you are able to substitute everything. And then you are able to collect your 3 marks there. It can be 3 or more. It depends. So you can get your 3 marks there by substituting. Don't forget K, your constant, 9 times 10 to the power of 9. Your charge for Y, it was 7,2 times 10 to the power of minus 9. Your charge for X was 7,2 times 10 to the power of minus 9 divided by the distance, but our distance between the charges must be squared. Then use the calculator. Calculate. Don't make mistake. Practice makes perfect. Draw a level vector diagram. So you can be expected here. They're saying we are going to bring a 3rd point charge. We're going to bring, remember we're bringing X and Y. They're bringing the 3rd one of unknown positive. Oh, this one is positive. That is the most important information because it's going to check how it relates to other charges because this one is a positive charge. And you know that positive and negative, they attract, negative and positive, they repel. So you are able to see that, okay, these two, this one is a positive towards negative is attracted. The positive towards negative is attracted. So you can see that Y must move that to the towards X. And Z must move because it's positive. It must move. Remember, I told you that the arrows are always towards the negative. So definitely, you can even see your vector diagram there to say, okay, the Y would be towards, and then the Z will be towards that. So Z is going to the right, Y is going towards the left. And you can even draw it like that and like that. We will definitely get you 2 marks. So those are our vector diagrams. Now, they are saying now the magnitude of the resultant electric field at the point X here, electric field, the resultant, the net electric field. So it means when you add that the electric field due to Z and electric field due to Y, they give us 4,91 times 10 to the power of 5 Newton per coulomb. Remember, Newton per coulomb is N, the dot C to the power of minus 1. Now, they are saying now the magnitude of the resultant electric field at point X is positioned, where point X is positioned is 4,91 times 10 to the power of 5 Newton coulomb. Calculate the magnitude of charge Z. So you can be asked to calculate that magnitude of the charge. So don't be afraid. Just go now and see that, okay, I will have E due to Z and E due to Y. And then when I add them together, I get E net. So we are just adding the two to say, okay, I will add these two. And then I will get my E net. And then you are able to see that, okay, my E net in this case is KQZ R squared plus KQY R squared equals to that. So we can substitute E net was given as 4,91 times 10 to the power of 5. And then you substitute everything, you will be left with QZ because it's unknown, that one. We know E net, we know the K, we know the R squared, we know the QY. So you substitute everything, and then you just make QZ subject to the formula. Please practice, and then you are able to determine QZ there, and it helps you as you prepare for your exams. Now, without wasting of time, we're left with the last 3 questions, which is our electricity, our photoelectric effect, our electrodynamics. So in order, question 8, electric circuits. 9, we are having our motors and generators, and then 10, we're expecting to have the last question, if the paper is still structured that way, our last question, which will be now a photoelectric effect. Now, electric circuits, we are emphasizing the definitions again to say no EMF. I always emphasize this one from your data sheet, from your definition of a potential difference, to say you're just including the maximum there, which is maximum energy supplied by the battery. Maximum energy supplied. Remember, your work done is your energy transferred. So it's the maximum energy supplied by the battery per unit coulomb of a charge. So you definitely have to get the EMF if you are asked to define it. And then we're dealing with the issue of internal resistance. You have done the experiment, I hope, and then you know what happens. Ohm's law, stating Ohm's law, remind yourself there. Remember the main thing, we're having the potential difference across the conductor, which is directly proportional to the current. Don't forget, we are saying that provided that the temperature remains constant. And then we have our series connection and our parallel circuits and power. And we are saying power is the rate at which work is done. And then you are able to say that, or the rate at which energy is transferred. So you are able to define power in this context. Our data sheet, there we have it. This is very much important, and this is what we will be using as we deal with the question. Without wasting time, let me move to say, well, given the circuit diagram below, it shows a battery with the EMF. The maximum energy supplied by the battery per unit charge of a coulomb is 12 volts. And we have the internal resistance of 0.5 ohms connected to 3 resistors, a light bulb, a switch, an ammeter, and connecting wires. The ammeter and connecting wires have negligible resistance. Good. I always say this, look at this as a journey. Our journey starts from positive. I always emphasize that positive is that bigger line and negative is that smaller one. So our current is conventional current. It moves from positive to negative. So we're expecting that our current is moving in this direction. But these 12 volts that we're having, remember, this is our total budget. We said is the total is the maximum energy supplied by the battery, a unit charge of a coulomb. So definitely we're saying these 12 volts is the maximum budget that we are having. But now, because we have internal resistance, we are simply saying you can't leave home without paying here. So when we leave internal circuit here, we won't leave with 12 volts because there is internal resistance that is saying, no, I'm resisting. You can't pass here. You must give me something. Of that 12 volts, something belongs to me. So definitely we know that the voltage that is going to leave and move the charges here, which we call it terminal or external voltage, it will be less than 12 volts because we have internal resistance. And if we check, we're having our charges, they will be moving, our charges will be moving. As the charges are moving, you are able to see that, okay, they have 2 options of taking that road and taking that road. And when they come there, they're able to see that, okay, we're finding 10 ohm light bulb there. We are passing 2 resistors in parallel. So because they are in parallel, we're able now to find their effective resistance by calculating the R 1 over R parallel equals to 1 over R1 plus 1 over R2. You are allowed here to use the product over sum only when you have 2 resistors in parallel. But if there are 3, you got 2. I will advise you to use the formula 1 over R parallel equals to 1 over R1 plus 1 over R2 plus 1 over R3. But when there are 2, you can be able to write the formula 1 over R parallel from the data sheet that I just showed you equals to 1 over R1 plus 1 over R2. Then you can just simply say product, which is R1 times R2 over sum, which is R1 plus R2. So you will simply have it as 1 over R parallel, which is in the formula 1 over R1 plus 1 over R2. I always emphasize that always use the formula first. And then immediately when you have that, you can just say, okay, R1 times R parallel equals to R1 times R2, which is product over sum. As long as there are 2, you can do that. But when there are 3, you will have difficulty using that. So definitely you are saying 10 times 10 over 10, 10 times 10, which is 100, over 10 plus 10, which is, so you're saying 10 times 10 is 100, over 10 plus 10, which is 20. 100 over 20 is 5 ohms. So you can see that why this together is 5 ohm. And then when you add this R series here, you are having R1 plus R2, R1 plus RL of the light bulb, you are able to get 15 ohms there. So you can see you are having 15 and 15, and this 15 and this 15, they are in parallel. So you can even use the product of a sum again, 15 times 15, 15 times 15 divided by 15 plus 15 to get the external total resistance that we're having here, external resistance. So I hope you understand that. Let's go to the questions without wasting time. That is not in our side. Switch S is initially closed. Switch S is initially closed. So they are saying now, look at this as being a closed switch. They say state Ohm's law without wasting time. The potential difference across the conductor is directly proportional to the current in the conductor at a constant temperature. Remember, don't forget that this applies, Ohm's law applies when the temperature remains constant. Now, calculate. So we're going to have 3 calculation questions. The first one, we're going to calculate the external resistance, which I think I've taken you through already. I've indicated that you will start there, you will do 10 times 10 over 10 plus 10, you get a 5, you add it to the 10 ohms there, you get a 15, then you say 15 times 15 over 15 plus 15, and then you're able to answer this question. And then the second question is saying, calculate the reading on ammeter A1. So we're going to calculate, remember we'll be knowing total R here, R total, plus the smaller R there, then we can get the total resistance of the circuit. Then we have the total voltage, EMF is 12 volts. So you know that current is V over R. So definitely when you have a V total, which is 12 over 0.5 plus the total resistance here, definitely you will be able to determine the current. That's what we are going to do. The last one, calculate the power dissipated by a resistor R3. So the question is based on this 15 ohm. Remember, you'll be knowing the current, and it's 15 and 15. Whatever the current that we are having is going to split equally because the two resistance, this resistance total is 15, this one is 15. So the current that we got here is just split equally. So you will know that the current, when you have resistors in parallel, the current will split. So let's go to the first one. Calculate the total resistance, which is what I talked about. And then you were able to say 10 plus that, you get your 15 ohms. That's what we did. Remember, we said 10 times 10 over 10 plus 10. As we did here, we get 5 plus 10 is 15. So that is 15 for that. Again, we have 15 times 15 over 15 plus 15. We get R for parallel, total there as 7.5. So you can use that method or you can use the other method. It's still fine. So that is 7.5, the R that we're having totally there. Now calculate the reading on ammeter A1. Now you can use, as I was indicating, remember, you know R parallel is 7.5, the external one, R internal is 0.5. So you can simply add the two and get R total is equals to V total, which is your EMF over I. Then you calculate your current as 1.5, or you can just go and use the EMF formula, which is IR plus R, which in this case is 12 volts equals to current. The R is 7.5 plus 0.5, and then you are able to determine your current, which is 1.5. Remember, we said when that current comes here, it's going to split. So it's important to know that, okay, it's 15 ohms for the first branch, and another 15 ohms this side. So because the resistance are equal, the current will split equal. So we have 1.5 amperes is going to split equally when it comes here, which means it will be 0.75 that comes here and 0.75 that comes there. So you're able to get that. And then when they say calculate power, you're able to say, okay, I know that I can be able to calculate my power by first have the understanding that is amperes. So for that, you see that the current is going to be split into 2, so it becomes 0.75 there. And then P equals I squared R, which is now equals to 0.75. And then the total, your total resistance, we said your total resistance was it is 15. So for that, by multiply by 15, and then you get 8.44 watts. So definitely you are able now to see that, okay, for me to be able to calculate power, already I know the current total is 1.5, but because this is 15 ohms and 15 ohms, it will split the current equally. Hence, we are going to say the current is 0.75 that comes to this 15 ohms, because they said we must calculate for R3, and then you're able to do your calculation and get power. Don't forget the SI unit for power is in watts, that capital W. It's important that you write that. I hope this helps you as you prepare for your electricity. Now, switch S is still closed. They said, okay, if the resistance of light bulb remains constant, how will the brightness of the light bulb be affected? Oh, switch S is now opened. Now, I want you to have understanding to say, when we open this switch S, remember we said the combination of this is 10 times 10 over 10 plus 10. We said this is 5 ohms. We said this is 15. So you can see the total RP that we calculated, we said is 7.5 ohms. So you can see that, okay, the total is 7.5, but immediately when you open this, the total will be this 15. So which means the resistance is going to increase. So they're asking you that by opening switch S, what will happen to the brightness? Definitely the brightness will increase. But they're saying, explain to us, why are you saying now when we open this switch, the brightness will increase? Let's do the explanation to say, okay, how is that important? We are saying the total resistance will become 15 ohms, so the total resistance will increase. And when the total resistance increases, remember the relationship between R and I, inversely proportional. So the total resistance increases, which means the current will decrease. And if the current decreases, remember it has an effect here. The current was 1.5, and then if you multiply that by internal resistance, which is 0.5, you are able to get your 0.75 as your internal voltage. Now, if you increase current, definitely the V internal will decrease as well. Remember, V internal is V equals to IR. So when this decreases, V internal will decrease as well. So V internal decreases, and V external, remember the R is increasing, V internal will increase. So the power input will increase as well. Therefore, the brightness will increase. So I hope you have the understanding of this type of equation to say, okay, I'm looking at, we are when we remove or when we open switch S, we are decreasing the total resistance. We're increasing the total resistance outside here. And when we increase the total resistance here, as we are saying, the total current will decrease. When the total current decreases, the V internal decreases, and then the V external will increase, and then the power output will increase as well. Hence, the brightness will increase because we have more V that is being coming out. Where is that V coming from? Remember, we're saying V internal is decreasing. It's not that the 12 volts is becoming more. We are having 12, we decrease V internal. When you decrease V internal, it now goes out as more voltage that is coming out. And when we have more voltage, we're going to have more brightness. That is the type of question that definitely I'll want you to answer. Our last two questions to go now is to say, question 9, we'll talk about motors and generators. They are saying now, the diagram below shows the essential parts of a generator. I think you know now already all this. The coil rotates within the magnetic field. So you're having the coil, and they're saying it rotates within the magnetic field. Write down the type of current, direct current or AC current. So your answer is either you're saying direct current or AC current. Okay? Induced in the coil. So in the coil, what type of current is induced? And then that will be your AC current. And then the type of the type of current that is passing through the 20 that is produced. Remember, we're having the commutator here, and the commutator produces direct current. So you can see that the one that is going to pass through the 20 ohms produced here, it will definitely be, be a DC power source. They said you must give a reason, and the reason is saying because we have a split ring. I would prefer just use commutator. I find it easier to just use the word commutator, but we can use them interchangeably. And then we are saying, due to the presence of commutator, the type of current that is moving here is a direct current current that we're having. Now, an alternating current generator using the commercial generation of electricity. Definitely in South Africa, we're using alternating current for the electricity that you are receiving at your home. State one fundamental difference in the design of what is the difference between alternating generator and direct current generator? Remember, alternating, we're talking about the slip rings. And when it comes to direct current, we're talking about commutator. So you're able to see that is the difference. AC has slip rings and the DC has commutator or slip rings, split rings. And then we're able to move. Now the question is, fully explain why alternating current is preferred. Why do we use alternating current instead of direct current for transmission of electricity over long distance? So you can see in our context, electricity is moving over long distance. Why do we prefer AC, not DC? The first reason is that it can be stepped up and down. Alternating current can be stepped up or down. So you can increase in voltage and decrease in current. So that is the reason. You can be able to transport a lot of it because there will be less power that is lost. So we don't lose more power when we are using the AC. So that is the most important thing about the source or alternating current. We prefer it because we are moving our electricity over long distances, and then we're able to step up. So which means we can be able to transmit a lot of voltage. But when it comes to your home, you are using your 240 volts, 220 volts. So it's able to be stepped down to the level of the one that you can be able to use at home. So hence that's the advantage of using the alternating current. Now, the calculation type of questions, they are given a graph here. They're saying an AC generator produces the following graph of EMF versus time. So we have EMF versus time. Write down the period for one revolution of the coil of the generator. I know in grade 10 we have done wave, sound, and light, so you still remember the period for one revolution of the coil of a generator. And then definitely you can see that you have it there, the complete cycle up to there. Then you are able to see that is 0.01 seconds. And then calculate the root mean square voltage VRMS for this generator. So when you're calculating your VRMS, you know you have your Vmax, which is 84.8 Vmax at the top there, over root 2. And then you just substitute and you get 59.96 volts. I look at these calculations as spend some time, sit there, do many of these calculations under these motors and generators. I'm telling you, you will be able to collect a lot of marks in terms of doing this type of calculations. And then calculate the resistance of a 40 watts ohmic bulb connected to the generator. So definitely you are having now your VRMS that you calculated as 59.96. So it's V squared over R. And then they said calculate the resistance. So you always just do data collection, go and choose the right formula. With that, you will never go wrong here. Data collection, choose the correct formula. You are able to know what to do. And you find your resistance is 89.88. Now, the last question for our revision session, which is photoelectric effect. You know, the word photo means light. Photo means light. So now in this one, we're going to look now at the ejection of electrons from the metal surface. So we're looking at a metal, and we're saying now when you bombard a metal with light of frequency, remember light is carrying what we call a photon, a packet of energy. So when you bombard a metal surface with that photon, which is E equals to HF, when you bombard a photon is this one. We said it's a packet of energy. Packet of energy, when you bombard a metal with that, we're saying the electrons on the metal surface will do what? Will gain the electron, will gain the energy. And when electrons gain the energy, they become excited, which means they move from low energy level to high energy level. And that is what we call excitation. But that is different from photoelectric effect. Here, photoelectric effect, we're talking about the removal of electrons from metal surface when light of suitable frequency is shown onto it. So when you show light of suitable frequency onto a metal surface, electrons will be removed. So very much important. In this case, we're given a photoelectric investigation. Light of different frequencies was radiated on each of the two metals. So we're having two metals, metal A and metal B. The graph of the maximum kinetic energy of the ejected electrons from metal A. So we're focusing on metal A, and the frequency of the incident photons is shown below. So this graph is for that one, is for A, and then it's showing you that. So the important thing, know how to interpret the graph. Remember when I started, I said the gradient of the graph is changing Y over changing X. Don't forget the gradient. You did that in your maths. And then we said the area of a graph, which will be changing Y times changing time. When you multiply this and that, you get your area of the graph. When you do that, you get the gradient of the graph. So it's important when you're dealing with this type of questions. So now they're saying point X on the graph represent an unknown maximum kinetic energy. So this is the maximum kinetic energy. And then they are saying, write down the numerical value of the gradient of the graph. So that is very much important. So you are even changing kinetic energy over changing frequency. So that is your gradient. So they're saying, what is the value of the gradient? The gradient under kinetic energy and versus frequency graph. So that is your Planck's constant, which is 6,63, your H, which is 6,63 times 10 to the power of minus 34. So you got to know that here the constant of this graph, which is the gradient of this graph, is H, which is our Planck's constant. So you know that. And then we're saying define the term work function. As well, I want to emphasize as well that the definitions here, we are saying know these three definitions. You can't write this question without knowing photoelectric effect, work function, and threshold frequency. Those ones, you definitely have to know them. You can sometimes we refer to threshold frequency as cut-off frequency, where we are saying is the minimum frequency required to eject electrons from the metal surface. And work function is the minimum energy required to eject electrons from metal surface. So you got to know those definitions. Definitely you are expecting to get one or two of those. In this case, they said define the term work function, where you are saying it is the minimum energy required or needed to eject an electron from metal surface, and then you get your two marks. Hope you're happy. Calculate the work function of metal A for 3 marks. Remember, work function is your W0, which is equal to HF0. So it means now it's important for you to be able to understand that the threshold frequency, where do we find the threshold frequency from this given information from the graph? H, we said, is the constant already, then your F0. Immediately when you get your F0, you are able now, with no doubt, to do the calculation. But I want to emphasize to yourself to say, for you, you will use the formula definitely. You know the H, which is your Planck's constant, times 10 to the power of minus 34. Don't forget, this is not 5. Our frequency here, threshold frequency F0, is not 5. It's 5 times 10 to the power of 14. So please do that correctly. 5 times 10 to the power of 14. And then you are able to multiply them. You get 3,32 times 10 to the power of minus 19. Remember, our energy or our work function energy is measured in joules. So it must be in joules there. So you are able to get your 3 marks. And then value of X, that is shown on the graph. So this one, saying for 4 marks, you can show us what is the value of this. Remember, you got your threshold frequency, your double zero. Now you want your maximum Emax. Remember, in terms of the formula, we are saying that E equals to work function plus EK max. Né? That's what we're having. And E, we said this is energy of the photon, and the energy of the photon is the same as HF, and that is HF0, and that is half mv squared. Just for you to know how to expand this formula, because some of the time we'll just give you this, and this is the information that will help you when you're dealing with this type of the question. And then without any wasting of time, for you to determine the value of X, you will definitely start with the gradient of this particular graph, because you know that the gradient, we said, is the Planck's constant, which is h. And then on the y-axis, change in y is x minus 0. That's what we have done there. On the x-axis, we have 12,54 times 10 to the power of 14 minus 5 times 10 to the power of 14. So you're able to see that change in x over change in y. And then just mass issue, you are able to determine x as 5 times 10 to the power of minus 19 joules, which is your maximum kinetic energy, the value there. And then you did well, and then they ask a question now, say, how will each of the following be affected if light of frequency 12,54 times 10 to the power of 14, but of higher intensity? I want you to have understanding. Learners have a problem with this issue of intensity. Remember, when you say intensity, we're increasing the brightness of that color. So we're saying, what happens now when how will each of the following be affected if light of frequency 12,54 times 10 to the power 14 hertz, but of higher intensity? When you say higher intensity, we're saying we're increasing the number of photons per unit time. Please increase the number of photons per unit time. Remember, one photon removes 1 electron. So when we increase the number of photons, definitely we're going to increase the number of electrons that are ejected. And if we increase the number of electrons that are ejected, we're expecting that current will, if we put an ammeter there, current will increase as well. So understand the importance of intensity. Now let's go to the questions. They said you must write only increases, decreases, or remain the same. Now, we have increased the number of photons, but we didn't increase their frequency or their energy. We just increased their number. It means they still carry the same energy. So X is kinetic energy, and kinetic energy, definitely remember from the formula that I told you, we said E equals to work function plus EK, which means now the energy that the photon brings, it must be divided to give the minimum energy required to remove the electron from the surface. The rest of energy is converted to kinetic energy. Now, if we increase intensity, we're increasing the number of these photons, the number of them, but they still carry the same energy. So there won't be more energy. What will be more? It will be more electrons that are ejected. Hence, when you answer this question, definitely you will say no effect. Don't say remain the same, because we said choose from increases, decreases, or no effect. Always check what you must write there. What will happen to the number of photoelectrons? I've talked about this. To say, immediately when you increase the intensity, you are increasing the number of photons per unit time, which means now more electrons per unit time will be ejected. So definitely this one must increase. Lastly, metal B has a larger work function than metal A. Metal B, remember, metal A is this one. So they are saying, no, we're having another one that has a higher work function than this one. metal A. It has a higher work function. Redraw the graph in your answer book. If remember, you have W0 work function equals to HF0, which means that the work function depends on the threshold frequency, meaning that if it has a higher work function, it means it has a higher threshold frequency, which means that graph definitely must be on the right of this one. And they said you must label it as B. So that is your total of 14 marks for this question. And then that brings us to the end of this session. But I want to close by saying time management is very much important. We are saying don't spend too long on one question. Move on and return later if needed. And we are saying show all the steps. Even if you are unsure, write something logical. Marks are often awarded for method. And we are saying stay calm and confident. Please, you have studied. Trust your preparation. Remember, you always, after data collection, you will always identify the correct formula, substitute, you write the correct answer with correct SI unit. And if you are dealing with vectors, you must be able to increase to show the direction. Don't leave any multiple choice question and calculation questions unanswered. Please write that formula, substitute into that formula, because they are saying calculate and they said calculate something, identify the correct formula, substitute, and don't leave multiple choice questions, calculation questions, answer all questions. Physics is not about memorizing. It is about understanding how the world works. Trust your reasoning and stay calm under pressure. Want to say preview for the next lesson. We'll meet again tomorrow just in time at 2:30 to 4 o'clock. Topic will be paper 2. So the focus will be paper 2. Always, as usual, anyone who has never made a mistake, has never tried anything new, try and do as many problems as you can. Till we meet again. Thank you very much.